Okay, let's jump right into this explainer. Today, we're exploring something absolutely crucial. We're looking at how a dedicated task force of over 40 healthcare professionals, regulatory experts, and technologists are actively building the future of safe, regulated healthcare AI. We are moving way beyond the theoretical here. What we're actually looking at are the literal blueprints for the next generation of medical technology.
To understand why this matters right this second, just look at this staggering number, $150 billion. That's the projected annual savings in the U.S. healthcare system alone, just from integrating AI agents. But, it's not actually just about the money. It's about addressing massive systemic pressures, like severe staffing shortages and crushing clinician burnout. So the stakes here, both financial and human, are incredibly high.
We've got a lot of complex ground to cover today, so here's our roadmap. We'll look at the AI agent revolution, the regulatory gap, risks of autonomous AI, borrowing existing frameworks, a new regulatory playbook, and finally, building the future.
All right, let's kick things off with Section 1, the AI agent revolution.
For years now, we've really relied on static, rule-based AI. It basically sits in a box, processes the data you feed it, and spits out an answer based on predefined rules. But AI agents, they are fundamentally different. They're dynamic, they're autonomous, and they're goal-driven. They interact directly with their environment, continuously learning and adapting. Think of it like the leap from using a static digital reference book to suddenly having a proactive digital medical resident right there with you.
And what's wild is that these agents are already moving way beyond basic background support. We aren't talking about simple spell checkers anymore. They're stepping in for complex administrative tasks, handling claims, managing scheduling, to actively fight clinician burnout. They're powering 24/7 conversational AI for patient engagement and even extracting sensitive data directly from electronic health records. They're doing the heavy lifting so clinicians can actually get back to direct patient care.
Which brings us right to Section 2, the regulatory gap.
So, the FDA regulates anything intended to diagnose or treat disease, but we have a massive mismatch on our hands here. The FDA's traditional pre-market approval process was built for static products. We're talking about things like MRI machines or fixed software algorithms. It fundamentally misaligns with AI agents because, as we just saw, these agents continuously evolve. I mean, how do you approve a medical device today when its learning mechanisms might literally change its behavior by tomorrow? Right now, our traditional oversight mechanisms simply aren't equipped for that kind of dynamism.
To combat this whole black box opacity of deep learning models, experts are demanding standardized transparency. And I absolutely love this concept, a nutrition facts label for AI. Just like you know exactly how much sodium is in your soup, doctors need to know exactly what demographic data train the AI diagnosing their patient. Because without that, we really can't fully understand the limitations or the biases of the tools making critical health recommendations.
Let's move on to Section 3, risks of autonomous AI. Because here's the reality. Poorly trained AI introduces terrifying new categories of risk. We're talking about safety issues like overfitting, which is where an AI essentially just memorizes training data instead of actually learning to solve real problems, or it might lack basic human empathy. Then you have massive privacy threats like prompt injection, where bad actors trick an agent into bypassing its own security. And then there's emergent behavior. That's when an AI develops totally unpredictable capabilities post-deployment, a process known as grokking. The bottom line? As autonomy goes up, the potential for catastrophic compliance and data leakage failures goes right up with it.
And because comprehensive federal policy remains pretty elusive right now, state governments are frantically scrambling to fill the void. States are basically acting as laboratories for policy. Get this, there have been over 250 health AI-related bills introduced across 34 states this year alone. It's incredible to see that much action, for sure, but it's also creating a chaotic, confusing patchwork of local laws for anyone trying to build a universally safe tool.
So how do we fix this? Let's look at Section 4, borrowing existing frameworks.
The good news is, instead of reinventing the wheel and starting completely from scratch, the industry is heavily leaning on the NIST AI Risk Management Framework to build a trustworthy foundation. NIST is the National Institute of Standards and Technology, and their framework provides a really mature, structured way to govern AI, define clear roles, and align organizational policies with actual risk tolerance.
As you can see, this is a very structured four-step sequence: govern, map, measure, and manage. It ensures threats aren't just theoretical, they're identified in the map phase, quantified with hard metrics in the measure phase, and actively mitigated with human oversight in the manage phase. And all of this happens well before an AI ever touches a clinical setting. And the task force isn't stopping at NIST either. They're integrating international standards like ISO 42001, which is actually the world's first AI-specific management system, and they're utilizing structured cybersecurity checklists like the OWASP framework. Basically, they're building a massive, comprehensive shield against cyber attacks by pulling the best existing blueprints we have from across multiple highly regulated industries.
Okay, moving right along to Section 5, a new regulatory playbook.
To solve that huge mismatch we talked about earlier between static regulations and dynamic software, they are proposing an incredibly innovative solution. It's called a living UDI, or an AI model passport. Think about it. Instead of getting a one-time stamp of approval, this passport continuously updates itself as the algorithm learns and changes out there in the real world. It accounts for evolving models and emergent behaviors, so traceability doesn't just stop the second the software leaves the lab.
And obviously, oversight has to scale up depending on the autonomy of the AI, right? At level 1, you have low-impact administrative chatbots. They're handling basic, non-sensitive tasks. Level 2 steps up to moderate risk. Think clinical documentation assistants handling sensitive patient info, but strictly under human supervision. But then you hit level 3. Here, we are looking at autonomous decisions with literal life or death impacts, like surgical robotics. You simply cannot regulate a level 1 chatbot the exact same way you regulate a robotic scalpel.
Because traceability is so absolutely paramount, regulatory compliance will require an unbroken artifact chain. This means if an AI makes a strange or harmful medical recommendation, developers will have an auditable trail. They can trace that logic all the way back through the continuous monitoring, the bias audits, the code architecture, and down to the very first piece of training data just to find out exactly why it happened.
And finally, that brings us to Section 6, Building the Future.
So who's building this? Well, the task force is driving incredible consensus by building these standards completely out in the open on GitHub. They are developing FDA-ready compliance frameworks, which they call HAARF, right alongside open-source security tools called QFIRE. This kind of totally transparent approach means any healthcare worker, hospital CTO, or cybersecurity expert can jump in and contribute directly to the safety of our medical future.
They are really attacking this problem from all sides, simultaneously. You've got the startup task force out there running real-world pilot tests to audit risks. The research task force is actively drafting solutions for proactive bias mitigation. And the education task force, they're physically building training programs for physicians right now so doctors know exactly how to interact with these new agents safely and effectively.
So, as we wrap up this explainer, I want to leave you with a pretty profound challenge. As these dynamic systems integrate seamlessly into our hospitals, we have to ask, when an autonomous AI agent makes a complex, life-saving decision, or, terrifyingly, a life-threatening error, who is truly accountable? Is it the developer, the hospital, the human supervisor, or is it the AI itself? How we answer this question is really going to determine if the future of medicine remains safe, equitable, and profoundly human. Thanks so much for exploring this vital topic with me. I really hope it leaves you with plenty to think about.